Okay, let's talk about the Green Revolution. This is a term that a lot of people haven't even heard of, yet it's been enormously important on the world scene. Has really transformed the way the world deals with food, is in large part responsible for the reduction in hunger around the world, even though it's still a problem. Certainly progress has been made on that. And the Green Revolution is the primary reason. So let's start earlier in history and discuss where the concept came from and why the world needs to worry about these issues and how big foundations and world governments have become involved in that. In 1798, there was an important document created called the Essay on Principles of Population by Malthus. He talked about how population increases and how the food supply increases, and raised alarm that population at one point, in fact he thought it would be soon, would outstrip the world's ability to create food. And what he said is that the food supply increases arithmetically, but that population increases geometrically. And that if there was balance between food supply and the population back when he was writing about it, or perhaps even some abundance, that would soon give way to the stark reality that population would increase in a way that would outstrip the food supply. And so here he's quoted in this essay as saying, the power of population is so superior to the power of the earth to produce subsistence for man that premature death must in some shape or other visit the human race. Now he was correct in noting that hunger was going to be a problem, but not for the reasons he thought. And so according to his idea, you'd expect a function that looks over time to be like this, that you'd expect the food supply to increase at a rate like this, but population to go like this. And so he projected that if you're out here, you're okay, but once you start to get into this territory, things wouldn't be okay. In fact, that's not the way the curves actually look. So if you look at time, going back even before 1300 and then go up to the projections for the year 2020, the Food and Agriculture Organization has created this plot. Now I'm sorry this isn't the crispest of graphs, but the lighter colored line here is the food supply and the population is in the red line that goes here. So this is quite different than what Malthus projected, and the question is why? What's gone on to explain what the model would have suggested and what the reality actually was? And what he couldn't anticipate at that time were a number of things. One is technology advances that made growing more food readily possible around the world. Birth control became an issue because he was making projections based on assumptions that there wouldn't be modern methods of birth control, and then he couldn't predict that there would be a green revolution. Those things combined have changed the plot of the graph to the point where we get the function that we do now. Now the Green Revolution has been a really important player in food history, but it's collapsed in a relatively short period of time given the evolution of major changes in agriculture around the world. So you can see going back, hundreds and thousands of years about what happened with different parts of the agriculture revolution, where agriculture, the domestication of animals that we talked about before, the specific cultivation of crops came in at one point. Those were major advances. But those took a long, long time to kick in. In fact, the Green Revolution has happened over only a period of about 45 or 50 years. So very impressive changes in a short period of time, and of course technology, globalization has made that possible. This is necessary because the world's population is growing at a very rapid rate and the world needs more food to survive. And the chart shows just how much different parts of the world are going to have to increase food production just in order to support the populations. So the United States, given how much agriculture it has, the world's largest producer of corn, for example, is still going to have to make a 30% increase in the United States and Canada, increase by 30% to help feed the people that are part of the population increase in those two countries. And then you can see the numbers are very high in Asia and Latin America as well. Latin America, an 80% increase in food production to support the population. That's a lot. But when you get out to Africa, the numbers are really very high. And it so happens, as I'll talk about later, that Africa is the part of the world least touched by the Green Revolution. So some problems definitely need to be solved. So today we're going to talk about the definition, history, what the Green Revolution is, and then its impact. And the impact is highly controversial. On one hand, the proponents of the Green Revolution make a very strong case that world food productivity has increased an awful lot, that this has helped solve, to some extent, the world's hunger problem, and that this is absolutely necessary for the stable function of human beings. The critics of it say that that's all fine and good, and those are important goals, but there are some negative consequences of the Green Revolution that most people haven't considered but need to. So we'll talk about both sides of this issue. So what is the Green Revolution? Well, it's basically the desire to increase the yield and decrease the amount of farming that's done around the world so that people can have more to eat. And so the word yield is an important concept in this context. It basically refers to how much productivity are you getting out of a certain amount of land. So if you're producing X bushels of wheat in Y area, and then you increase the yield from the same area to 2X, then that's considered a good thing. And so a lot of the Green Revolution focuses on yield. And these are the ways, the primary ways, that the Green Revolution has sought to do that. Irrigation becomes a very important issue, and you can greatly increase in certain parts of the world the amount of crops you can grow by irrigation. In fact, in some parts of even the U.S., you simply can't grow crops unless there's irrigated land with water brought in from other places. Fertilizers become a major issue and, of course, increase yield. Pesticides increase yield because the crops aren't getting eaten so much by other things. And then there's technology and biotechnology that's involved here. And then part of the whole Green Revolution, and this is probably the most controversial part, but not the only one, is the genetic modification of foods. Because you can genetically modify crops to have certain properties that will increase yield, make them more resistant to drought, more resistant to certain pests, etc. And those have become a big player in the Green Revolution. The critics of this say you're releasing something that could be pretty disastrous on the world. That is, these genetically modified crops, and we don't know what they're going to do to the ecosystem. We don't really know what they do to human beings, etc. So there's some people that are pretty alarmed about that part, where others say that this genetic modification is an absolutely necessary and vital part of the Green Revolution. The term itself was introduced in the 1960s. There's some controversy about who came up with the term first, but some reports that I've seen suggest that this individual is the one who first coined the term Green Revolution. The concept existed before then. People were doing things that, and you'll see examples of that back in the 1940s, that were consistent with the concepts of Green Revolution, but the term didn't come about till later. So the hope here is to reduce and eliminate hunger, equip the world for the rising population, and more or less to feed and clothe the world. So the companies that benefit from the Green Revolution, the biotech companies, the agribusiness companies that sell the genetically modified seeds, that sell the fertilizers, sell the pesticides, basically talk about the wonders of the Green Revolution, feeding and clothing the world. There's debate about how it's accomplishing that, but that's the hope at least. The whole concept of the Green Revolution really got its impetus and its initial birth from the Rockefeller Foundation. Headquartered in New York City, the Rockefeller Foundation back in the 1940s decided that world hunger was a massive problem and wanted to intervene, and then created a program that really spurred the Green Revolution. It so happens that the current president of the Rockefeller Foundation, Judith Rodin, was a professor in psychology here for some time, then she was provost at Yale, was then the president of the University of Pennsylvania, and now is president of the Rockefeller Foundation. So there are some Yale ties there with Judy Rodin. The person who's considered the pioneer of the genetic revolution is a man named Norman Borlaug. Borlaug was a chemist with DuPont, the DuPont company, but got brought aboard by the Rockefeller Foundation in 1944 to spearhead this effort of the Green Revolution. He made an enormous difference in the world, and he led teams of investigators and scientists to go around the world and use new strains of crops, especially wheat, look at new growing techniques of biotechnology and things that existed at the time to increase the productivity in these areas. Here's a, let's see if we can get it to go. Here's a picture of him later in his life. He's very well known for developing this disease-resistant strain of wheat. Now, I'll give you some examples with cotton of that concept. He started with Mexico, but then went to Pakistan and India, made very large differences in these countries because the Mexican experiment that went first was considered such a success, and he was awarded the Nobel Prize in 1970 for this work. There are key moments in this, and Borlaug was instrumental in all of them. In 1945, the Green Revolution, as I mentioned, began in Mexico, and it was especially driven by changes in wheat production. And the population was rapidly growing in Mexico at that time. Borlaug and others helped develop healthier strains of wheat that could resist the various threats to it, and as a consequence, the self-sufficiency of the country of Mexico went way up. Some years later, building on that success, as I mentioned, Borlaug and others took the Green Revolution to India, where mass famine was occurring at the time, and tried to increase rice yields by the use of different strains of rice that people called miracle seeds at the time. So these were a couple of landmarks in the Green Revolution. The major focus of this, as I mentioned before, was to increase the use of pesticides. Now, you can start to guess about what some of the concerns about the Green Revolution might be when you're starting putting more chemicals on farm fields. But if pests are devouring crops, lowering productivity greatly, and people are starving, then pesticides become a necessary part of that picture. Increase the use of fertilizers for obvious reasons. That has the same set of concerns that it generates, but the same set of opportunities. The irrigation we'll come back to in a minute, and the word cultivars has to do with changing the nature of the seeds that you plant. So what you're cultivating can change, and that itself can increase productivity. So what gets put in the ground becomes part of it, the seed part of it, and then what's done to it afterwards becomes part of the picture as well. And the goal is to do these things, and here's where the word yield comes in, but the word yield has a number of different components. So increasing the number of acres being farmed around the world becomes an important priority because, of course, that's one way to increase food output. They want to have fewer people. One of the aims was to have fewer people involved in producing food because that means that you're able to produce the same amount of food with less labor, and that increases productivity. Now you can begin to think about some of the concerns with that. America, as we'll talk about later, used to be a nation of a great many farmers with relatively small areas they were farming. The number of farmers has gone way down in a short period of time. I'll show you graphs on this later. But the number of acres per farm has gone way up. And so that's where you get into factory farms. They're called vast acreages that are used for raising animals or for growing crops. So the productivity per person effort has gone up, but the number of people involved has gone down. And the critics of this phenomenon, this trend, have talked about how farming has become big business. We're more detached from food. Political issues political power of the big farming institutions are driving food choices and driving nutrition policy in the U.S., et cetera. So that's one of the downsides of it potentially. If crops mature earlier, then of course a single unit of land can produce more crops more often. Better response to the fertilizer, so if you genetically modify the crops or systematically breed them to be more responsive to the fertilizers, and potentially at the same time less more resistant to pests, then of course you can increase productivity. And these other things are pretty self-evident. So there are a number of different pieces about the green revolution. So if you really get down and say, what is it supposed to do? What are the things it's supposed to do are all these things. And you can see how many different inputs would be necessary to produce these. Fertilizers, pesticides, irrigation, genetic modification of foods, all these things are necessary. So I'll give you two examples of the green revolution in action, and we'll talk about some of the consequences of these. So one would be a technology advance, which is the use of irrigation, higher use of irrigation. And then we'll talk about biotechnology and genetically modified foods. It's a very interesting issue. And we'll come back in a later class and loop back to some of the concerns about the genetic modification of foods. But for the most part today, we'll talk about the upside that is part of the green revolution. So the early technology advances that have been made, some of them are interesting, and there will be familiar names you're going to see associated with some of these. So in the early 1700s, one major advance was from this man whose name is Jethro Tull. Now some of you who like rock music may recognize the name of a rock band that was popular in the 60s and in the 70s to some extent. But Jethro Tull himself got famous for making the seed drill, which was a mechanized way of planting fields. In 1831, this fellow became prominent in the whole agriculture world. His name was Cyrus McCormick, and you may remember from high school history that he was credited with developing the reaper, which was a way to harvest the crops and to greatly increase the efficiency of a farmer being able to harvest things, especially wheat. In the 1830s, this man became popular. His name was John Deere. He was famous for developing a particular plow, a steel plow, made a company out of this, and then of course we all know the John Deere company of today. So these people were important players. A particularly interesting bit of technology has to do with irrigation. If you think about the fact that we're growing vast amounts of crops in pretty arid land in California, for example, lots of the vegetables and things that are grown in California are grown in pretty arid land, and irrigation is necessary to make them grow. You get a picture of what might be involved in the water resources necessary to grow our food. And where does this water come from the most part? Well, water in these sort of places, or in some of the arid areas, is not necessarily pumped from the ground. It is not part of the local ecosystem, but is basically brought in from outside. And so you've probably heard some of the debates over the years about water that is in the Colorado River that gets funneled off to various places in the West, like Las Vegas, not for growing crops, but just for supporting the city, to California for growing crops and the like. And then places get in water wars about this, and the cost of water, and who has to pay for it. Does the government subsidize it? These all become issues. But as I'll mention in a later class, the depletion of natural water stores is a major concern in certain parts of the world, a major concern. So the amount of water that we're using for agriculture has a downside, but also an upside, of course, because it greatly increases productivity. There are lots of types of agriculture. Those of you who have flown on airplanes between here and the West Coast, when you get to the Colorado area, in other parts of the West, you'll see the irrigation that you see on the right, which are these big circles where you have irrigation coming out from the middle in these big machines that provide it in circles. But other places have different kinds of irrigation. There are many different types. Irrigation is done in different ways. So if the water is to be drawn from a local resource, here would be an example of that happening. That you'd have some kind of a holding area like over here that would be a lake, a spring, or something that was generating water. Maybe it would have to be brought in from the outside. But then there would be these piping systems, there would be pumps in different places, and that would deliver the water to the various parts of the farm. And then there are smaller versions of this too, where there might be a holding tank for water used in smaller plots of land, but all driven by a power type thing like a pump. So that would be when the water has to be moved from one place to another. There's some places where gravity will work. The water's coming down from a mountain, let's say. an irrigation system is brought up. There are little trenches built in various places, and the water gets funneled off into the farm, but mainly it's pumped in different places. So there's an energy cost of that as well. So when you think about how much energy it takes to grow specific crops, and when we talk about sustainability, we'll start to talk numbers with that, then the amount of energy it takes to bring water from one place to another is part of that overall picture. In the developing world, irrigating crops becomes very important because, of course, some of these areas are quite prone to lack sufficient water to grow these crops. So there's a particular type of well that very often gets used in these areas called a tube well, and you see a diagram of it on the right and people creating one on the left. They're easy to do. You just have to drill a hole, go down and find a water source, and then pump the water up with a pretty inexpensive little pumping system. It can be done by hand, or it can be done mechanically or with a pump, but one way or another the water can be brought to the surface. Now, one of the questions is how clean the water is that gets brought to the surface, and I saw a statistic just the other day that there was concern in Bangladesh in particular that the aquifers that are being tapped into by these water sources are pretty high, and some of them are pretty high in arsenic. So the cleanliness of the water becomes an issue. But for the most part, it's considered a good thing when people are given the technology and the resources to drill these kind of wells, because then they can generate water to help support their crops. Here an example of tube wells on Pakistan on the left and Bangladesh on the right. So these would